So now we are discussing about the power plant engineering. So unit 1, coal based thermal power plant. So what are the topics we are going to discuss about? That is called Rankine cycle. So what are the improvisations of Rankine cycle, layout of model coal power plant, supercritical boilers and FBC boilers, turbines, condensers, steam and heat rate, subsystem of thermal power plants, a fuel and ash handling system, draft system, feed water system, and binary cycles and cogeneration system. These are all the main system we have to discuss in the coal based thermal power plant. So power plant is an assembly of a system or subsystem. We have to generate the electricity mainly. So these are all the interconnected components which is convert from energy one form into another form. So today every country energy needs, we need energy sources. Okay, so there are several sources are available like as a fossil fuels, coals, petroleum products, chemical energy reactions, nuclear energy reactions. These are all the main energy. Whereas the geothermal energy we have to discuss in this topic. Next, what are the conventional energy sources? What are the conventional energy sources means fossil fuel energy, hydraulic energy and nuclear energy. These are all the conventional energy sources, whereas the non-conventional energy sources means solar energy, wind energy, tidal energy, wave energy, geothermal energy, biomass energy. So today every countries need the energy consumptions, energy developed systems, right? So what are the location of power plants? Mainly we have to location of the power plants. The location is mainly based upon the hydroelectric power plants. Is usually predetermined by the available water and the water head which is utilized. For conventional based low thermal power plants, for the following factors to be considered. So availability of cooling water. If cooling towers are used to the possibility of the adequate make of the water. So and availability of the fuel and distance from the center of gravity of a load demand, and the cost of land, character of soil, main wind direction and water currents in the cooling water source, and with coal fire stations disposition of as if the plant is created far from the town, accommodation of for staffs, rail and road connections, security considerations. These are all the main considerations for we have to construct the power plant, right? So this is the layout of modern coal power plant, right? So what are the components? Coal storage. What are the components available in the layout of modern power plant? So first one is called coal storage, and next one is called coal handling, and ash storage, ash handling, boiler, economizer, low pressure heater and high pressure heater, whereas a feed pump, condenser, turbine, generator, cooling tower, cooling pump, air preheater and exhaust gas chimney. Like that, these are all the components of layout of modern power plant. So first one is called coal and ash circuit, second one is called air and flue gas circuit, and third one is called water and steam circuit, and fourth one is called cooling water circuit, right? So coal and ash circuit, that is means the circuit consists of coal storage, ash storage, coal handling and ash handling systems. The coal handling system consists of a belt conveyors, screw conveyors, etc. Whatever we have in the conveyors. Next one is called coal and from the storage. Coal from the storage is called coal storage is yard in the transfer the boiler furnace by means of the screw conveyor, belt conveyor, whereas the ash resulting during the combustion of coal in the boiler furnace is removed and it is stored in the ash storage devices through ash handling, right? So Indian coal contains mainly 30 to 40% of ash, and a power plant of 100 megawatt produces normally 20 to 25 tons of hot ash per hour. So next one is called ash and flue gas circuit. This circuit consists of air filter, air preheater, dust collector and chimney. So air is taken from the atmosphere and it is sent into the air preheater. Then the dust is collected from the air is removed by using the series of air filter. Then waste heat of flue gas is passed to the chimney in the preheating of air in the preheater, right? So next one is called feed water and steam circuit, and this circuit consists of a boiler, feed pump, boiler, turbine and feed water heaters. Mainly the steam generated in the unit boiler passes through the superheater and it is supplied into the steam turbine. The steam is expanded in the steam turbine, then it is passed to the condenser where it is condensed. The condensate heat is heated in the high pressure heater and the low pressure heater using the steam tapped from the different points of the turbine, right? So the feed water is passed through the economizer where it is further heated, like where it is generated, like where it is generated. So where it is generated, like the feed water is passed through the economizer where it is furtherly heated by means of the flue gases, right? So this is the main circuit. And next one is called cooling and water circuit. The circuit consists of the condenser, cooling water pump and cooling tower. Evidently quantity of the water is not much more enough than the Rankine cycle. Whereas the characteristics of steam power plant, what are the characteristics of steam power plant? Is mainly it produces the high efficiency and it reduces the water requirement and it is highly reliable and available, right? And this is the main, what are the main advantages? We have to consider the main advantages of the nuclear power plants or as a steam power plant. The power production does not depend on the nature mercy and the initial investment is very low. And next, the plant can be located in the nearby the load center, so the transmission of the cost and the losses are considerably reduced. So the time requirement for the construction and commissioning of the thermal power plant is required less period of time. And steam power plant having mainly there are some disadvantages of steam power plant. So first one is called, as compared with the hydroelectric power plant, life and efficiency are less and the transportation of fuel is the major problem in this type of power plant. And whereas the power generation cost is considerably high when compared to the hydroelectric power plant. And the air pollution is the major problem inviting the additional investment. It cannot be used as a peak load plant. The coal fuel is needed, may be exhausted by the gradual use, right? So we all know the what is mean by the dryness fraction, what is mean by the wetness fraction. We all know that everything, right? So we have to go the next topic. This is called the layout of a Rankine cycle. This is mean by furnace, flue gases, exhaust gas to stack, and we have to use the superheater, evaporator, and economizer. Whereas the steam goes to the steam turbine, whereas the steam utilized into the steam generator, and the steam next it is condensed in the condenser. And next by using the pump, right? And next thing, what are the improvisations of Rankine cycle? So reheating, flue gas reheating, live stream reheating, combined flue gas and live stream reheating. And what is the regeneration means? Ideal, single stage and two stage, and combined reheating and regeneration. These are all the main topics of improvisations of Rankine cycle. This is the reheat Rankine cycle, right? Reheat Rankine cycle. We are using every time we using reheat Rankine cycle, we are using high pressure turbine and a low pressure turbine, right? So this is the PV diagram of the reheat Rankine cycle. This is the regenerative Rankine cycle. This is the general layout of regenerative Rankine cycle. The first one is called boiler, turbine. We are using the condenser and using the feed pump. First of all, we have to send to the boiler 1 kg of steam into the turbine. The turbine not fully utilize the steam. Some amount of waste steams are sent into the condenser plate. We have to condense it into the water. Then it is pumped into the feed heater, and then it is sent to the boiler. This is one of the regenerative Rankine cycle, right? So this is a regeneration Rankine cycle layout diagram. So next we have to go to the boiler. So what are the classification of what is meant by boiler? The boiler which is used to the, we are using the water which is converted into the steam. Then the steam is utilized in the steam turbine. This is called boiler. So whereas the heat energy is converted into thermal energy. The thermal energy is converted into the mechanical energy in the steam turbine, right? The first classification is fire tube boiler and a water tube boiler. So what is meant by fire tube boiler and what is meant by water tube boiler means if the hot gas is passed through the tubes and the water is circulated around the tubes, it is called fire tube boiler. Okay. So example we have to take it as a Cochran boiler, Lancashire boiler, and a locomotive boiler are the main examples. And a water tube boiler, if the water is circulated through a large number of tubes and the hot gases passed around the tubes is called water tube boiler. That is called examples Babcock, Wilcox boiler and a Stirling boiler, right? Then supercritical boiler means a drum type boiler, one through boiler. So drum type boiler we are using the steam separator drum, and a one through boiler. So this is a one through boiler. So one through boiler means we have to utilize the steam as a distribution header, evaporator, and evaporator to wall, and it is separated into the steam turbine, right? This is called one through boiler. So next we have to go for the high pressure boiler. So high pressure boiler is first one is called lemon boiler. So lemon boiler is nothing but we have to use the preheater, economizer, superheater, convective evaporator and radiant evaporator. And the outside is feed pump, steam separating drum, stretch and distributing header, circulating pump, combustion chamber, superheated steam steam to prime mover, blower, exhaust gases out, and hot gases, hot air inside in the combustion chamber. So these are all the main topics we have covered in the power plant first one, that is called coal based thermal power plant, right? And that is called this is one of the Benson boiler. So this is a major difference for the convective evaporator, radiant evaporator. We have to eliminate in the Benson boiler. This is a convection evaporator. We have used a grate in the bottom of the boiler, right? This is called Benson boiler. So as is the same working principle as compared to the lemon boiler. So it's nothing but hot air passes through the combustion, hot air into the combustion chamber. So first the water is from the hot well, then it is sent into the heat pump. So we have to preheat the water and it is sent into the economizer. Then it is sent to the superheater. Then it is sent into the steam separating drum. The steam, whereas the steam separating drum separate the steam and water. Then it is sent into the circulating pump, whereas the radiant evaporator, and it is sent into the convective evaporator. Then we have to use it in the superheater. Then finally the exhaust gases passed out from the lemon boiler, right? So a lemon boiler and Benson boiler, both the working principle are as the same. We discussed, right? And then it is called low effluent boiler. Another one is low effluent boiler, and another one is called Velux boiler. So low effluent boiler is nothing but low effluent boiler, the evaporating drum is in the bottom of the boiler and it is drained out. Whereas the steam circulating pump, radiant, we are using the steam circulating pump, radiant superheater. First the fuel is sent into the boiler, then it is heated into the by air preheater. Whereas by using, we are using the economizer. The economizer is nothing but we have to preheat the air from the exhaust gas. That is called, this is the purpose of the economizer. Then we are using convective superheater, superheated steam to the turbine. We are using the mixing nozzles in the low effluent boiler. Next one is called Velux boiler. This is a major in the high pressure boiler. So first we have to use the feed pump by using the economizer. Steam separation section, we have a major part is the steam separation section, and we are using the water circulating pump and axial compressor. Whereas the convective superheater is sent into the steam to prime mover, whereas the Dock's circuits are the steam